In this lesson, we're going to start reviewing some quadratics, ideas, properties, forms, things we should know about quadratics. Our whole next unit is going to take the things we learned in grade 10 and extend them somewhat into new areas of quadratics. So some basics. How do we recognize a quadratic? Easiest way is if you have a table of values, find your differences. Finite differences are the differences in your y values. Okay, and back in grade 9, we learned if you had a constant difference in your first differences, it always went up by the same number or down by the same number. That would be a linear relation. Last year we talked about second differences. That would be a quadratic relation. And for our purposes, if it's neither one of those two things, we just say it's something else. And we will learn about other functions down the road, just not yet. And to calculate differences, usually you work from left to right or bottom up to see the right signs. So if I'm looking at this first example here, I go from 10 to 20, 20 to 30, 30 to 40. I'm going up by 10 every time. That's my first differences. The fact they're all the same tells me my function is linear. If we try the second one, looking at the y's again, I went up 3, then I went up 5, I went up 7 in our first differences. Those aren't the same, so we try it again. Our second differences, we went up 2, we went up 2. Those are both the same. It's quadratic. Once you get something that's the same, don't try it again. You end up with a bunch of zeros. That won't tell you anything. If those weren't the same numbers, you would stop. You would just say nonlinear or quadratic. It's a neither function. Some properties we should remember about quadratics. Quadratics are these U-shaped curves. They had 7 really important properties we learned about last year. Our vertex, that's that point right there where we change directions. It has coordinates, 1, 4. Our zeros, the 2 points where we cross the x-axis. Zeros have other names. They can be called roots, they can be called solutions, they can be called x-intercepts. There are 2 of them, and they both have a 0 in them. That's why we actually usually call them zeros. Our axis of symmetry, the imaginary line that goes vertically through your graph. It's the mirror down the middle of your graph, if you will. It has an equation, x equals, all vertical lines are x equals, and it's the x coordinate of your vertex, this piece right here. So x equals 1. Your optimal value is the highest or lowest value that your function reaches. So our optimal in this case goes as high as 4. It's the y part of your vertex. Do we have positive or negative second differences? Well, that and the direction of opening and the max min, which are our next 3 points, are all connected together. When things open down, as this one does, it gets wider as you go down, then they have negative second differences. And if you have negative second differences and you open down, that means you have a maximum. So knowing any one of those 3 things tells you the other 2. If you had a min, you know it opens up. If it opens up, it has positive second differences. And those are some of our basic properties from last year. Okay, some forms. Now, first day of our course, we graph some things, remind us of how to do some quadratics, graphing. We're going to look more intensely at it today. One of our forms is called factored form. A, if we think about functions here, is our direction of opening and our stretch factor, our size factor, if you will, the vertical stretch when we talk about functions. S and T are your zeros. Okay, just remember to change your signs when you take things out. Okay, so if I'm looking at this thing, the first one, my A value is my direction of opening. The fact that it's positive tells me it opens up, and negative would open down. So direction of opening is all about your A sign. Okay, not a sign, A sign. The zeros are these 2 things, S and T. The only trick is we've got to change our signs. So negative 4, 0, and 3, 0. The axis of symmetry. If you go back for a second to our picture here, you might notice our axis of symmetry is in the middle of our parabola. And we can find our axis of symmetry by averaging our zeros. It goes halfway in between both of those. So the way we usually do this is we take our zeros, add them together and divide by 2. That'll get you an average. So negative 1/2, or if you want to, negative 0.5. Make sure you have the x equals at the beginning, because there's an equation for this. And then our vertex. Well, our vertex is made up of 2 parts, an x and a y. The x part is your axis of symmetry, because it goes through the vertex, as we said in our previous picture. To find the y, we take our equation, and we replace the x's with our axis of symmetry. Right? Make sure you're using the equation, so it's the +4 and the -3, not the zeros, okay? So we'll get 3 times 3.5 times negative 3.5. Multiply that all together, and you calculate for that one, and we should get negative 36.75. And there is your vertex. I call that V for vertex. Okay, you guys try the second one. Pause it if you need to. Try it. See if you can figure it all out. Okay, this thing opens down because my A value is negative. My zeros, well, one of them is obvious. It's 2, 0. That one's a little trickier. The number in here, oh, sorry, in here, we don't see it. It's actually a 0 there. Anytime you have a letter by itself, that means you have a 0 at 0. Kind of like when we did rational functions and you had a letter on the bottom, one of the restrictions was 0. Axis of symmetry, add them together, divided by 2. We'll get 1. And then our vertex, gotta figure out the y part. So negative 2 times 1 times 1 minus 2, or in other words, that. And we get a vertex of 1 and 2. Okay, there's factored form. We also should know about vertex form. Again, we graphed this on day 1 of the course, but just reminding us of some of these basic properties. Okay, we like vertex form. It's a great form for graphing because you can see your vertex, H and K. Just be careful with your sign on H. And your A, your stretch factor, your direction of opening, is the same as it was in factored form. And it's the same as it was when we deal with functions. So if I want to graph this first one, actually, sorry, we want to find the vertex of the first one. The vertex is going to be 3 and negative 1, my H and my K. Just be careful to change your sign on H. Our direction of opening, our A value is a positive, so it opens up. Our axis is symmetry. Well, we know that because we know the x part. X is 3. Our optimal value, we also know that because we know the y part. It's negative 1. If I want to sketch this, I start at 3 and negative 1, and then I use my step pattern. My step pattern is 1, 3, 5, but I need to multiply it by a, which in this case is a 2. So what's 2 times 1 times 3 times 5? We'll get 2, 6, and 10. So we can go over 1 and up 2, over 1 and up 6, and over 1 and up 10. If this doesn't fit, so don't worry about that point. We'll do the same thing in both directions. So we make symmetry. Okay, and that's our fast way of graphing a parabola. Step pattern and vertex. We need to have it in vertex form. Oh, missed a page. Okay, last idea. We want to be able to write equations of these parabolas. The way we learned last year is plug in the information that you know, whether it's a vertex or your zeros. Yeah, that's step 1. Step 2, you need to know a point, an x and a y. Okay. Solve for a, because you never know what a is unless they tell you, and then write the equation. Just be careful when you're subbing in that you change the signs on values going into a bracket. For example, your zeros or your vertex. So if we try the first one here, what do I know? Step 1, what have I been told? I've been told that I have zeros. If I know zeros, I'm going to use factored form. Factored form looks like a bracket x minus s, x minus t. My zeros are these two things. So when I put them in, I've got to change their signs. X minus 6, x minus 8. I've been told a point, an x and a y in other words. I can put those in for x and y. Now all I need to do is solve for a. So I'm going to follow BEDMAS. I'm going to do the stuff in the brackets. I'm going to multiply all these together. That's going to give me 15a. And I'm going to solve it. A is 1. My last step, write the equation out. A is 1. And I had an x minus 6 and an x minus 8. Okay, you guys are going to try 1? Okay, what do we got this time? Find the equation of a quadratic in vertex form. Vertex form. So we need to know about our vertex. A bracket x minus h squared plus k. Okay, so we know our vertex. We got our h and our k. Be careful when we put things into brackets. We got to change our signs. So x plus 3 now. Don't forget the squared and the plus 5. We have our x and our y right here in our point. So 2 for y, negative 2 for x. And now we got to solve. Now trick you into solve a little bit. Let's do our brackets first. We've got 1 squared plus 5. Okay, the 5 needs to come over with the numbers. Okay, this is multiplying. That's 1a. But the 5 needs to be with the other part. Solve for a. And write out our equation. A is negative 3. X plus 3 squared plus 5. Okay. A little bit of homework here to try. Just a couple questions there. Basic stuff with quadratics. We're going to start adding some new things in every day. This is just our little warm-up first.